The development of technology entails not only amazing discoveries, but also more and more prohibitions related to the preservation of the environment. However, sometimes such prohibitions only further motivate scientists and engineers to come up with completely unique devices. One of these is the hero of our video today, the light supersonic aircraft X-59 QueSST. But before we tell you what stage this promising project is at, let's revisit how the concept of the supersonic passenger aircraft was born. The 1960s were full of interesting ideas and boundless optimism for humanity. The horrors of World War II were behind, and the unlimited potential of technological progress was open before mankind. The US and the Soviet Union actively competed against each other in the field of space achievements, and it seemed as if any day someone might create their own colony on Mars. The parallel development of civil aviation brought countries and continents noticeably closer. The era of jet aircraft was in full swing, and by the end of the decade, there was even a new name in the world of civil aviation, the Boeing 747. Which for many years remained the only double-decker airliner of its kind. All major countries were sure that the future of aviation lay with the supersonic aircraft. Europe worked on the Concorde. The USSR built the Tu-144, which received the nickname QueSST from the foreign media for its obvious resemblance to its iron colleague. Meanwhile, the United States has, since the 1940s, been actively studying potential problems related to supersonic flight for combat and passenger aircraft, working with experimental models such as the legendary Bell X-1. As part of the SST, or Supersonic Transport Program, U.S. authorities filed a request for the creation of a supersonic airliner by one of the leading American aircraft manufacturers. Boeing won the competition, after which, at its facilities in Seattle, Washington, a team of specialists began work on the 2707 project. The aircraft was supposed to be noticeably larger than the Concorde, accommodating 250 to 300 passengers and having a cruising speed of about Mach 3. All in all, the 2707 should have been a worthy example of American industrial excellence, but its Achilles heel was sound. Or rather, the sonic boom when the planes broke the sound barrier, which can be heard for several miles. In the case of low-flying aircraft, the force of the sonic boom was enough to shatter windows in nearby houses and knock people off their feet. It was not clear how much the inhabitants would be able or even willing to get used to the fact that loud bangs would be heard over their heads all day long. To test this, the Federal Aviation Administration, or FAA, conducted a controversial experiment, Operation Bongo 2. During this, 1,253 sonic booms were produced over Oklahoma City, Oklahoma, during the 6 months of 1964. This type of experiment was somewhat tolerated by the public due to economic dependence on the Mike Monroney Aeronautical Center and Tinker Air Force Base. Some were delighted with such an honor for their city, and the local Chamber of Commerce even arranged a festive dinner on this occasion. Starting February 3, 1964, the U.S. Air Force produced 8 sonic booms per day, from 7 a.m. to the afternoon, with the help of F-101, F-104, and F-106 fighters, as well as B-58 bombers. The result of the experiment was 147 broken windows on the 2 tallest buildings in the city within the first 14 weeks of testing, and the constant rumble from the sky began to annoy many citizens. This culminated in a series of protests by local activist groups and coverage of the trending issue in popular East Coast newspapers. City officials received 9,594 building damage complaints, 4,629 official damages claims, and 229 claims totaling $12,845. Senator Monroney, in turn, was very upset by voter complaints and demanded regular reports from the FAA on the progress of the experiment. However, the FAA program soon lost the support from a key person in Monroney, and the negative publicity of the test partially influenced the cancellation of the Boeing 2707 in 1971. and ultimately the complete abandonment of the U.S. design of the SST. In addition to this, since 1973, the FAA officially banned all commercial supersonic flights. After the phasing out of Project 2707, the entire SST area fell into disrepair. Concorde, meanwhile, survived until 2003, faced with many technical problems, after which it also retired. But this by no means meant that the largest American companies gave up. In order to get around the main enemy of supersonic aviation, the sonic boom, the Lockheed Martin Skunk Works team, in collaboration with NASA QueSST mission, as part of the Low Boom Flight Demonstrator program, began developing a silent supersonic aircraft, X-59 QueSST, which stands for Quiet Supersonic Technology, although many jokingly call him the son of Concorde. Work on the aircraft started back in 2016, and by 2018, NASA signed a contract with Lockheed Martin in the amount of $247.5 million. Moreover, the main goal of this entire undertaking at the Skunk Works was not so much the production of a mass model for a supersonic passenger airliner for regular transportation, but rather the desire to prove to federal regulators that it was possible to create an entire fleet of supersonic aircraft that generate the same noise as conventional subsonic passenger flights. The creators of the X-59 wanted to show the world a supersonic aircraft, the sonic boom of which would resemble the ordinary slamming of a car door, and not frightening thunder. This Lockheed Martin aircraft is equipped with unique shaping and supersonic technologies. The long, thin nose, the placement of the engine on the top of the vehicle, and its external vision system are all designed to control the strength and position of shock waves to produce a softer sound and less disturbance for those on the ground. The point isn't to completely eliminate shock waves, which in truth is impossible, but to design the apparatus in such a way that the shock waves will be located about equally along its length. Due to this, they won't merge into the shock waves that form the double shock boom, but are instead individually weakened and softened. The low boom plane prototype is 94 feet long, has a wingspan of 29.5 feet, and a maximum takeoff weight of 32,300 pounds. At its heart will be a 13-foot General Electric F414 GE100 engine, providing 22,000 pounds force of thrust, allowing the craft to reach a top speed of Mach 1.42, or 940 miles per hour at 55,000 feet, which is about 25,000 feet higher than a standard commercial Airbus. Its installation took place at the Lockheed Martin Skunk Works in Palmdale, California, in early November of this year, marking the completion of assembly and the imminent approach of taxi testing, and most importantly, its first flight. In an effort to not reinvent the wheel, the plane will use some elements from its colleagues at the shop. For example, when designing it, the X-59 was equipped with a 3-post retractable landing gear from the F-16. The training Northrop T-38 Talon became the donor for the cockpit elements, and the control stick was borrowed from the F-117 stealth fighter. Yes, it sounds like we're dealing with a Frankenstein plane, but unfortunately, the ambitions of even the most talented engineers must fit into the budget. Designing the same components from scratch would require Lockheed Martin years of development, testing, and certification. However, when it comes to innovation, time is a much more valuable resource than millions of dollars. The planned sonic boom of the X-59 will be around 75 PLDB, while the Concorde's figure varied between 105 and 110 PLDB. Aluminum alloys became the basis of the design, but the steering wheel and the skin of the bearing planes are made of composites. During the design, the Skunk Works team took into account the sensitivity of critical areas on the body to thermal loads, since the tail unit is made of titanium alloys. One of the integral elements of the development of the X-59 was digital engineering. According to X-59 design leaders, unlike traditional aircraft, where they made extensive use of wind tunnels to shape and understand the flow around the configuration, they used thousands of computer simulations in the X-59 to characterize the nuance of every single flow feature on the airplane. The Skunk Works team wanted to scrupulously evaluate the shape of the aircraft, using aeroelastic modeling and examine its impact on the boom to attain desired boom levels. By the spring of this year, the creators of the X-59 had checked the cruising condition, and the results obtained differed from those expected by only 10%. It's precisely because of advanced computer engineering that it was much more convenient to create and develop such an aircraft today, rather than 30 or 40 years ago. But no futuristic aircraft can do without compromises. Here we have a flush cockpit, meaning that a long and pointed nose cone will greatly interfere with the pilot's view in front of him. Skunkworks went crazy with the decision to use Enhanced Flight Vision System, or EVS, which consists of a front 4K camera with a 33° by 19° field of view, and completely compensates for the pilot's lack of line of sight. United Technologies subsidiary Collins Aerospace was selected by the Lockheed team to supply a modified version of the ProLine Fusion cockpit. This will help pilots navigate even better where an aircraft's sonic boom will create the most noise impact on the ground, allowing it to be minimized. Additionally, the aircraft will receive the EVS 3600 Multispectral Infrared Advanced Vision System, a state-of-the-art technology that combines shortwave and longwave infrared and visible HD cameras into a tri-band system. This killer combination provides the aircraft with passive terrain scanning, eliminates interference due to low levels of illumination in the area, and identifies all types of threats. In other words, with such systems, pilots can forget about poor visibility due to fog, snow, smoke, and the other whims of Mother Nature. Speaking of timing, flight tests will start in 2023 to 2025, and the results will be reviewed by the ICAO, or International Civil Aviation Organization, and the FAA by 2027, after which it will be possible to discuss further tests in the airspace over cities. From the very beginning of its existence, the Skunkworks division has positioned itself as a team poring over the most promising developments. And something tells us that if successful, we'll be able to see their achievements and fruits of this experimental supersonic aircraft not only in civil, but also in the military aviation of the future. After all, who, if not Lockheed Martin, will be able to allow us to get from one end of the Earth to the other with a breeze, since they previously gave us the SR-71 Blackbird and other no less daring aircraft. Do you think the Skunkworks will be able to convince the FAA to reconsider its views on supersonic travel? Share your opinion in the comments below. And if you enjoyed the video, please leave a like, subscribe to the channel, and hit that notification bell for more content like today's. Thanks for watching, and we'll see you in the next one.